Imagine you're setting up a new office. You don't just throw computers on the floor and hope they talk to each other. You wire them up, segment the space, set rules about who can enter which room, and maybe run a private line back to headquarters. Cloud networking is exactly the same idea, just in software. Welcome. In this video, we are breaking down AWS networking, from building your private cloud network from scratch, all the way to securely connecting it back to your on-premises data center. Whether you're brand new to cloud or just solidifying your foundations, you're in the right place. We'll cover two big categories. One, networking foundations, that is the core building blocks. And two, hybrid connectivity, how you bridge AWS with the rest of your infrastructure. Let's dive in. Here's the problem. When you spin up a server on AWS, you don't want it exposed to every other customer's resources on the platform. You need isolation. That's exactly what Amazon VPC, Virtual Private Cloud, gives you. A VPC is a logically isolated section of the AWS cloud where you define your own virtual network. Think of it as your private data center inside AWS. You choose the IP address ranges, you decide the layout, and you control who gets in and out. A VPC spans an entire AWS region. Inside it, you carve out subnets, smaller IP blocks tied to specific availability zones. A VPC can span multiple AZs, giving you the resilience to survive a data center outage. Let's look at a use case. A fintech startup launching a payment platform creates a dedicated VPC per environment, that is production, staging, and development. This is to ensure workloads are fully isolated. Their production VPC spans 3 availability zones for high availability, while the dev VPC stays small and cost-efficient. Inside a VPC, you create subnets, that is, ranges of IP addresses bounded by an availability zone. You'll typically have two types: public subnets for resources that need internet access, like web servers, and private subnet for resources that should stay hidden, like databases or application backends. Route tables are what make traffic flow. Every subnet is associated with a route table. Simply put, a set of rules that tells the VPC router where to send traffic. A route pointing to an internet gateway, that subnet becomes public. No such route, it's private. Take, for example, an e-commerce platform, which places its load balancers and web tier in public subnets while keeping its RDS database and internal microservices in private subnets. Route table enforces this separation automatically. So, your resources are inside a VPC. How do they reach the internet, and how does the internet reach them? Enter the Internet Gateway. An Internet Gateway is a horizontally scaled, highly available VPC component that allows communication between your VPC and the internet. It's not a single device. It's a managed AWS service, so there is no bandwidth bottleneck and no single point of failure. Attaching it to your VPC and adding a route to it is all it takes to make a subnet public. A use case would be a news website running on EC2 instances and needs to serve millions of readers globally. By attaching an internet gateway to their VPC and assigning public IP addresses to their web servers, they can serve traffic directly from the internet. Here's an important scenario. Your database server in a private subnet needs to download software patches from the internet, but you absolutely don't want the internet to be able to reach it directly. How do you do that? The answer is a NAT Gateway, Network Address Translation. It sits in a public subnet and lets private resources initiate outbound connections to the internet while blocking any unsolicited inbound traffic. It's like a one-way door. Your resources can reach out, but no one can knock from outside. NAT gateways are fully managed by AWS. No patching, no scaling worries. You just pay per hour and per gigabyte of data processed. An example is a healthcare company that runs backend processing servers in private subnets and need to pull security updates and connect to third-party APIs, but they must never be directly reachable from the internet due to compliance requirements. NAT Gateway is the perfect fit. AWS gives you 2 layers of network security. Think of them as 2 different types of bouncers at your club. Security groups are stateful firewalls at the instance level. Stateful means if you allow traffic in, the response is automatically allowed out. You don't need to write a separate rule. Security groups are attached to resources like EC2 instances or load balancers. Network ACLs or NACLs operate at the subnet level. They are stateless, meaning you must explicitly define both inbound and outbound rules. They process rules in order from the lowest number to the highest. The best practice is use security groups as your primary firewall with fine-grained rules and use NACLs as a cursor subnet level backstop. For example, to block non-malicious IP ranges. Take for example, a gaming company opens port 443 on their web tier security group for HTTPS traffic, while a NACL blocks an entire IP range that was causing a DDoS spike. 2 layers, 2 purposes. All right, you've got your VPC built. But here's the reality for most enterprises. They can't just abandon their on-premises data centers overnight. They still have legacy systems, compliance requirements, and existing infrastructure. So how do you connect your AWS VPC to the rest of your world? That's where hybrid connectivity comes in. The quickest way to connect your on-premises network to AWS is through Site-to-Site VPN. It creates an encrypted IPsec tunnel over the public internet between your on-premises network and your AWS VPC. On the AWS side, you attach a virtual private gateway to your VPC. On your end, you configure your customer gateway device, which could be a physical router or a software appliance. AWS provides 2 redundant tunnels for each VPN connection, each supporting up to 1.25 gigabits per second of throughput. It's fast to set up, typically within hours, and relatively affordable. The trade-off? Since the traffic runs over the public internet, performance can be inconsistent, and it's not ideal for latency-sensitive or high-bandwidth workloads. A real-world use case would be a retail chain needs to rapidly connect 50 branch offices to AWS to access a centralized inventory system. Site-to-Site VPN gets them connected within a day, with no need for physical circuit provisioning. It's also a common backup option for more dedicated connections. Now, if you have high-throughput, latency-sensitive workloads, think large-scale data migrations, real-time analytics, or financial trading systems, a VPN over the internet isn't going to cut it. You need a dedicated line. That's AWS Direct Connect. Direct Connect establishes a private, dedicated network connection from your on-premise to AWS. It bypasses the public internet entirely. You get consistent network performance, reduced data transfer costs compared to internet-based transfer, and bandwidth of either 1 gigabits per second, 10 gigabits per second, or even 100 gigabits per second. There are 2 connection types. 1, dedicated connections. This is a direct physical port between your equipment and AWS. And second, hosted connections. This is offered through AWS partner providers and is great if you need smaller bandwidth increments or a faster on-ramp. One important thing to note, Direct Connect does not encrypt traffic by default. For compliance-sensitive workloads, you can layer a site-to-site VPN on top for encryption or use MACsec for link layer encryption. Let's look at an example. An automotive manufacturer runs a data analytics platform on AWS that processes sensor data from millions of connected vehicles. That is terabytes of data per day. Using Direct Connect at 10 Gbps, they achieve consistent, low-latency data ingestion and cut their egress costs significantly compared to internet-based transfer. Here's a real scaling problem. Your organization has grown. You now have 20 VPCs, one for each business unit. Without Transit Gateway, connecting them all would mean creating a mesh of VPC pairing connections. With 20 VPCs, that's potentially 190 individual connections. Managing routes across all of them? A nightmare. AWS Transit Gateway solves this with a hub-and-spoke model. It acts as a centralized cloud router. Each VPC connects to the Transit Gateway, and through it can reach any other attached VPC or on-premise network via VPN or Direct Connect. One connection to the hub, access to everything. Transit Gateway supports thousands of VPC attachments and uses route tables to control which spokes can talk to which. So you can isolate production from development or prevent 2 business units from seeing each other's traffic. You can also pair transit gateways across regions, giving you a global backbone entirely within the AWS network. For example, a global financial services company with 150 VPCs across multiple AWS accounts uses a single transit gateway per region, paired across regions, to build a global network. Security inspection is centralized through a dedicated inspection VPC attached to the hub. All traffic flows through it before reaching its destination. Here's one more challenge for the enterprise crowd. Your Direct Connect circuit connects to one AWS region, but your workloads span multiple regions. Do you need separate physical circuit for each region? That would be very expensive. Direct Connect Gateway solves this. It's a globally available, free-to-use routing service that lets you associate a single Direct Connect connection with VPCs across multiple AWS regions from a single point of management. Data doesn't flow through the gateway itself, it only distributes routing information. Combined with Transit Gateway, you get the full picture. Direct Connect provides the dedicated physical link, Direct Connect Gateway distributes routing globally, and Transit Gateway acts as the regional hub connecting hundreds of VPCs. Take, for example, a multinational retail company has a single Direct Connect circuit from their London data center. Using Direct Connect Gateway, they connect that one circuit to VPCs in EU, Ireland, EU Frankfurt, and US East, all without needing separate physical connections to each region. Let's bring it all together. You now have a solid mental model of AWS networking across two layers. First, networking foundations, your cloud building blocks. Amazon VPC gives you a private, isolated network in the cloud. Subnets organize your resources into public and private tiers. Route tables direct the traffic. Internet gateways open the door to the internet. NAT gateways let private resources reach out without being reachable. And security groups plus network ACLs give you layered defense in-depth security. Secondly, hybrid connectivity, bridging AWS and your world. Site-to-Site VPN is your fast, encrypted bridge over the internet. Direct Connect is your dedicated, high-bandwidth private highway. Transit Gateway is your cloud router, simplifying massive multi-VPC environments. And Direct Connect Gateway extends a single circuit's reach across multiple AWS regions. The key pattern to internalize: the right tool depends on your requirements. Need a quick connection on a budget? VPN. Need consistent performance and high bandwidth? Direct Connect. Managing dozens of VPCs? Transit Gateway. Multi-region with one physical circuit? Direct Connect Gateway. AWS networking is a layered discipline. And once you understand how these services solve real problems, everything starts to click. Thanks for watching, and I'll see you in the next one.